Harish Kumar, Andiyathan and Gokul is going to uh, explain about the design thinking based approach on where the compiler design concepts used. Harish explain what is the design thinking stages.
Okay, so the design thinking stages, using that we are going to understand about the compiler design concept. So the design thinking stages are empathy. The first stage is empathy. I'm going to explain about the empathy. So our problem statement is let us delve into the shoes of a coder here. So what basically a coder does is he writes the code in any language like Python, Java, C, C++, etc. And he wants a desired output based on that code. But the problem is machine can't understand that code. So we have to find the idea in where the Python code or Java code needs to be converted into machine level code so that machine can understand it and give us the desired output. So here the compiler comes into the place, which acts as an intermediate to convert the high level code to the machine level code. So let's continue further.
Hi, I am Rahul. Coming to the define part, the major problem problem is converting the higher level language into a machine level code. There are three problems in converting this. First, we need to translate the high level programming code into a machine level code. Also, we need to while converting the high level code to machine level code. It will take large lines of code, like thousands and lakhs of code. And also we need to review of codes to be optimized. We need to handle the errors and also
to the ID part. Our idea is we want some external syntax to the code which helps to segregate the machine language from high level programming language. For example, if you write something program in high level language that human can understand, but machine can't understand. So this is the problem. For this, we have to segregate some group of words from the high level language. We have to assign new meaning to the high level language through some lexical tokens. After getting the lexical tokens, we passing through the syntax analysis. It's like a grammar for English. Same way, machine language also expects some grammar. That's semantic analysis. After semantic analysis, it generates a rough draft like intermediate code generation. This is the format that result of the high level language to machine language in previous step. After the intermediate code generation, the intermediate code get optimized. The optimized result is known as optimization of code. After getting optimized, it produce the final output as a machine language. That machine language only can understand. For example, you tell something have to print. The print function can human understand, but machine can understand. The print function have some code in it. Using that code, machine can understand. We have to print something. Then after that open parenthesis, the content inside the print function get printed. This is the working flow of this idea concept. Coming to the prototype, we have to segregate the part of compiler named as a compiler. First part is high level language. The conversion part named as a compiler part. It have separate extension for this. This extension part hold a machine language which are converted from the high level language. So this is the prototype. First you have to write something in understanding your language. That understanding language is translated or converted into machine language. This is the compiler main process. So this is the prototype of the.
Okay, so now that we have developed a typical model of the compiler, what we have to do next is to test that compiler. If the compiler is working well, giving the desired output that we are looking for, or etc. etc. So how can we test the compiler? Like in regular coding, we can test the compiler by printing a basic code like print hello world or printf hello world. So this is the basic code that every coder tests. So if that works correctly, then we can go for a higher level code and we can go to limits like developing an operating system. So in this way we can test the compiler so that we can check whether it's working properly or not. If any errors are identified, we can use that for correcting the errors and making the compiler more better.
In the conclusion part, the problem statement is converting the high-level language in machine language. So we are creating a compiler design which converts the high-level code in lexical tokens and also create an intermediate code and then optimize and assembly code so that the computer can easily understand. So that's our problem.
So I asked one question. So instead of a normal engineering process flow, you have a define ideate and prototype. You are including the design thinking approach as an empathize part. So what is that advantage of
Identify by using what we can do is we can identify all the key problems from the view of a coder. We can see the viewport of a coder, and if he faces some critical problems, then he can mention that, and we can solve that particular problem. Instead of solving the regular problems, we can delve into the coder's mind view and solve that.
So using the design thinking approach, we are implementing any problem statement means the outcome is it is an error free, isn't it?
Yes.
So in a normal approach, suppose you have you could not get any expected outcome means we have to again backtrack and do the process again for analysis. Once you empathize, after empathizing only you are done that given a definition and then iteration and then prototype. So the main objective or the main advantage of designing approach is our outcome of the product should be the effective one and the efficient one as a end user.
Yes.
Isn't it? Thank you.
Thank you. Thank you.